Good afternoon and welcome to an EAS Consulting Group webinar on food safety and packaging presented by EAS independent consultant Thomas Dunn. EAS is a member of the certified group of companies and FS&S Food Safety Net Services and is a global leader in testing and regulatory solutions for FDA, USDA, and their regulated industries. EAS network of over 150 independent advisors and consultants enables EAS to provide comprehensive consulting, training, and auditing services, ensuring proactive regulatory and quality compliance. Today, we are fortunate to have as a presenter Thomas Dunn. Thomas is an expert in flexible packaging, including products, processes, and platform development, as well as intellectual property and food safety compliance. He assists EAS clients with problem solving in the event of packaging failures, conducts validation and verification programs to assure safety of direct food contact packaging, and more. He is the author of numerous publications and book chapters regarding food safety and packaging, and has served as chairman and on technical committees for the Flexible Packaging Association and is an elected fellow to the Society of Plastics Engineers. Additionally, Tom has served as an advisor to the Prepackaged Food Radiation Safety Research Group of the International Atomic Energy Agency. He has a degree in chemistry and biology from Yale College. With that, I will say thank you again for joining EAS. We will save all questions for the end, and you may add them into the Q&A box. And I will turn the presentation now over to Tom.
Thank you. I hope you're going to enjoy the exploration of packaging and food safety that I have ready for you today. As I'm trying to indicate over here, I think of packaging and food safety as a multidimensional issue. The forgotten food ingredient aspect of food packaging as a risk-based preventive control, and food packaging as the consumer's communicator. Food safety of the package addresses the food ingredient dimension. Food safety by the package addresses the risk-based preventive control dimension. And food safety for the consumer is about the consumer communicator. I'll speak later about food safety for the package when I get to explain to you some of my thoughts on good manufacturing practices. To talk about food safety, I first have to make sure we're square on the notion of the food safety hazards, biological, chemical, and physical classes of hazards for food safety, and understand some of the regulatory language that attends to the understanding of what a package is when it's a container for food. The package in regulatory language is this container. It's comprised of one or more materials. Materials I consider basically a commercial entity, something for which a specification and a purchase order, consumer, supplier, customer relationship exists. It's how the material supply chain to support the manufacture of food packaging containers works. Those materials are in turn comprised of one or more substances. Substances are simply chemicals, something with a CAS number, something that can be identified with any one of a number of analytical methods and can be specified in terms of its chemical makeup and its chemical purity. In the United States, packaging substances are regulated by the US FDA if and only if they are reasonably likely to enter into the food product inside the package. In that case, they are a de facto food additive or an indirect food additive in the language of the regulators. If it could be entered into the product, then that substance requires pre-market clearance, which takes the form of a compositional statement and then a requirement for suitable purity. In the European Union, the regulatory concept is rather different, particularly with plastic packaging. Only those substances which are on the positive list of the European Union Directive for Plastic Packaging Materials can be used in food packaging, and those are subject to migration limits with respect to the overall materials coming out of that substance and then specific chemicals that might migrate from that substance. I'd like to try to simplify this notion of both composition and suitable purity because I think they're important to keep your sanity when you're managing food safety for packaging materials. I'd like to think of the United States situation as having one approved list, but the confusion comes about because there are many ways to end up on that list. Materials are grass, generally recognized as safe. They're listed in 21 CFR as a result of food additive petition approval. They're the subject of an FDA letter under a prior regulatory procedure that's no longer used by the agency, or under calculation of the threshold of regulation in terms of the minimal risk presented by a given substance in the food package, and more recently by the food contact notification process, which is the current way substances are listed by USDA for use in food packaging. All of these means to the list are going to provide specifications and limitations on the use conditions, particularly the chemistry and the temperature at which packaging materials and the food inside the package may interact between the food processor and the food consumer. And I'll point out that all of these levels of the food package, the container, the materials, and the substances are to be produced with good manufacturing practices, a concept that I'll spend a little bit of time trying to explore with you. Simply put, the notion of composition means, firstly, do no harm, the same as the Hippocratic Oath that attends to the relationship between medical professionals and their patients. Now, to understand and simplify purity, we have to look at good manufacturing practices for packaging. This is food safety for packaging, if you will. This took the better part of 8 years for me to get straight in my head, but GMPs are part of a world of lists of things, including prerequisite programs, PRPs and RPCs, that are part and parcel of the food safety management system. GMPs are particularly recognized in the risk management world and the regulatory world that reflects that. PRPs are part of the HACCP world and certified food safety management plans. RPCs are part of the FSMA regulations in the United States, which require risk-based preventive controls in hazard analysis and RPC plans, HARPC plans. What's similar about all of these lists of things is that they are the same practices, programs, or controls, just by a different name. But what's different is the fact that there are different rules for when any one of those practices, programs, or controls is required and when they might be exempted, and how those respective practices, programs, or controls have to be validated or verified in your safety plan. So to understand GMPs for packaging, I'll refer to the USDA definitions for their hazard analysis, risk-based preventive controls, HARPC plans. A hazard means any biological, chemical, or physical agent that has the potential to cause illness or injury. Keep in mind that an agent is a thing that has the potential to cause illness or injury. And that potential is quantified by another term that's different but related. That's the risk term. Risk is the possibility of loss of health or an injury as a result of a hazard. So keep in mind that a risk is going to be a number, a percent between 0 and 100, or a decimal between 0 and 1.0. To simplify packaging GMPs, keep in mind that GMPs are present to mitigate the risk, to mitigate the possibility of loss of health or injury that's resulting from a hazard in the process under management. And let's look at GMPs for packaging letter by letter. I would suggest that the good in GMPs concerns the effectiveness of mitigating the risk that's present in the process. It can mitigate a given risk when it reduces the severity of that hazard when it does appear in the process, or it can reduce the frequency of that hazard's appearance in the process. Both of those are suitable considerations for the goodness of a practice mitigating a hazard. Manufacturing is, of course, a process that produces a product. The product is food packaging. In this case, it's not the food itself. The difference is the fact that in making packaging compared to making food, the risks from different hazards are different depending on the severities and frequencies of those hazards in the particular process being considered. And practices similarly depend on the risks that are present in the process and their severities and frequencies. To put some sense to that, let me suggest to you that GMPs are very much like speed limits. And speed limits, in my mind, are just risk-based preventive controls in the traffic safety management world. Again, we have an agent that has the potential to cause illness or injury. The agent in this case is some sort of vehicle of a ton or more in weight and mass, moving at 100 to 400,000 feet per minute. The risk is all the way from minor injury to death. So a pretty broad range of severity there associated with the risk. Good depends on that range of risk, severities, and frequencies. One of the dependencies is weather conditions. In this image, we see a snow-covered limited access highway somewhere other than the United States because the electronic maximum speed limit is posted at 70 kilometers per hour. Don't be like my friend driving into Canada a couple of years ago and thinking that posted number is miles per hour. In this case, the speed limit is actually more like 40 to 45 miles per hour. The speed limit is restricted. The preventive control is a restriction on the driver and her vehicle in terms of lowering the frequency of spin outs from slick road conditions or reducing the impact of a rear end collision because of the extended braking distance necessary under the slick conditions. Now, those circumstances are very different in this speed limit case. This is a speed limit that attends to a school for certain times of the day on certain days of the week. In connection with the previous good speed limit, that the agent is the same, that vehicle going at some speed, and the risk is the same, minor injury to death. Good still depends on the specific risks, frequencies, and severities that are present in the context of the area where the speed limit applies. In particular, in this case, it's the presence and skill of a lot of pedestrians that are just not there present on the limited access highway. You have young school children in the schoolyard, and maybe you have balls bouncing out of the schoolyard into the roadway and children chasing after them. Good is different depending on the context, the frequencies of risk and their severities. So good manufacturing practices for packaging in the United States depend. The composition of packaging substances as regulated have a definition and specifications and limits provided by the FDA. The purity associated with those packaging substances has to do with how well GMPs protect those packaging materials from presenting hazards to the food packaged in them. And there's also a general caveat of the US FDA that specifies that substances and packages must be present at the minimum level necessary to achieve the technical ends of that substance's presence in the container. It's very different in the European Union. Here, GMPs are required and defined as verified quality assurance and quality control systems that are used to produce packaging. It's a performance specification that requires that the packaging manufacturer understand what's important to his customer in the context of the risk management programs present in the food processing world. I would suggest that even though HARP-C plans are not required for manufacturing food packaging under the new Food Safety and Modernization Act, managing good manufacturing practices are required for manufacturing packaging, and food processors buying food packaging materials must understand that their suppliers are using GMPs to produce those products for the food that will be inside of them eventually. Now, to get another perspective on GMPs for packaging, let's look at the hazards from different categories of agents, categories being biological, chemical, or physical. In particular, the microbiological hazards we're concerned with are various parasites, environmental pathogens, and other kinds of pathogens from other sources that might cause illness, particularly even death in the consumer of the food product. I'll ask you to accept as fact my statements that mold is a biological hazard and that mold will grow on bread but not on crackers, and ask you why. And I'll ask you what risk, remember that's a percent number from 0 to 100, is presented by mold on a food product, and ask you to do a thought experiment and consider whether mold will grow on plastic, metal, glass, or paper. The answer to these questions and the explanation of the statements that I provided for you is inherent in the food science measurement called water activity. It's defined as the measure of the energy status of water in the system. A higher water activity indicates a greater potential for water to support microbial growth, and to support chemical and physical reactions that require water, and for the migration of that water molecule from one food matrix to another matrix. The definition is very straightforward. It's the ratio of the water vapor pressure above the sample food matrix at a particular temperature divided by the water vapor pressure over pure water at that same temperature. So again, we have a ratio somewhere between 0 and 100% that is used to define water activity. On a decimal basis, that's 0 to 1.0. So in this table on the left, we have decimal indications of the water activity limits below which these microorganisms cannot grow. Here at 0.7 water activity, we have the practical limit for the growth of mold on various food matrices. Here we have our bread with the water activity of 0.9 to 0.95, and our cracker down here at 1.0 to 1.3. And I'll ask you to reframe my previous thought experiment in terms of trying to think of the water activity of basic packaging materials like plastic, metal, glass, and paper. Just by way of spoiler alert, I won't give you the detailed answer, but the water activity of most packaging materials is too low to support microbial growth. That doesn't mean that biological hazards on packaging materials are not present. It means that a single vegetative cell on that packaging material can contaminate the product inside the package if that product has a high water activity, and then that vegetative cell will grow inside the high water activity product. Similarly, spores on that packaging material can contaminate a high water activity product inside the package, and they will germinate and start to produce vegetative cells that in turn cause a risk to the user associated with the contaminated product from the package. The best example of that I can provide you is the difference between good manufacturing practices for pasteurized milk compliance and for aseptic milk packaging acceptability. The pasteurized milk ordinance specifies that single service containers for milk and milk products, when they're made out of paper, have a CFU measurement less than 250 per gram of paper. When that paper is formed into actual containers in the container swab, the limit is less than 50 CFU per centimeter square of swabbed area. And in all those samples, the material must be free of coliform organisms. In contrast, aseptic milk imposes a limit on the initial bioburden of packaging materials as an average less than 10, and that average is comprised of at least 10 samples. The maximum level of contamination on any one of those samples must be less than 50. But in addition, there's a performance specification that says the containers must be free of viable organisms that are capable of reproducing in the food under normal, non-refrigerated conditions of storage and distribution. The difference between aseptically distributed and stored milk and pasteurized distributed and stored milk is the requirements on the biological contamination of the packaging materials in which those two different processes put their product. So one last look at GMPs for packaging, this one by comparing it to food manufacturing GMPs. Our biological risk category, as we've just discussed, is less for food packaging manufacturing than for food processing. Similarly, it has a lower frequency and a lower severity than does actual food processing manufacturing activities. In contrast, the chemical and biological hazards associated with food packaging manufacturing are actually very similar to those in food processing itself, and so they are regulated similarly and they are mitigated similarly. So again, let's consider what are good risk-based preventive controls for food packaging. I'll point out that in the United States, you'll never find out from the US FDA. They are required by US FDA regulations, and there are incomplete and occasional references to GMPs provided in specific regulations. However, keep in mind we're manufacturing packaging, not ice cream, where the HARP-C plan is necessary. We're also not modifying the kind of medical devices, pharmaceuticals, vegetable juices, or seafood products that have their own specified GMPs under the relevant US FDA regulations. Instead of the FDA, I would refer you to the International Standards Organization standard ISO TS 2202-4, which has to do with prerequisite programs for manufacturing packaging. And remind you again that in the European Union, you have to produce food packaging using verified and validated QA and QC systems. And I'll suggest that if as a food packaging manufacturer, you have a food safety management system certified to the Global Food Safety Initiative standards, you will comply with the EU GMP requirements for your manufactured food packaging materials. I'll also suggest that if you have a workable quality management system under the ISO 9001 system, you will have the appropriate procedures and policies and actions that ensure compliance with the EU packaging system. But that is conditioned on having a good system that really pays attention to consumer expectations in the marketplace. We've been talking about the inconvenient truth that food packaging may add hazards with their attendant risks to the product inside the package. But along with that, there's a happy corollary. Packaging mitigates various risks as a risk-based preventive control. And in doing so, packaging, there is food safety from packaging. In particular, look at the functions of packaging as the packaging profession looks at the 4 basic reasons you use and buy packaging for your products. Number 2 is to protect and preserve the contents, exactly what we're trying to do with risk-based preventive controls. And the mission statement for a package is the same regardless of its size or the distance of its transportation. Here we have a kilogram or so of sugar in an intermediate bulk container. And here we have just a fraction of that, a couple of grams in a tiny paper poly packet the size of your thumbnail. The mission of both of those packages, from ridiculous to the sublime, is the same: to escort contents from source to destination. So in packaging mitigating risk, the basic functionality of that package is to provide some sort of barrier between the product and environmental hazards. If that packaging barrier ranges somewhere from a little bit more than 0 to less than or equal to 100%, sorry, that should be 100, not 00, I'd suggest that that barrier is present in every case. At the minimum level, that barrier functions as a dust cover that keeps chemical and physical hazards from coming to rest on the packaged product and then contaminating the product when it's consumed by the consumer. At a 100% barrier functionality, you have a hermetic package, which basically keeps everything in the package, and then anything out of the package, so that it functions to keep commercially sterile, shelf-stable products like that aseptic milk, in fact, sterile and in fact, shelf-stable. Packaging can also provide stable and predictable conditions for the product. One way is to modify the atmosphere inside the package to be different than the external environment outside the package, so that any toxic gases or chemicals inside in the environment around the package are not there to contaminate the product directly. Or thermal packaging that similarly insulates the product inside the package from thermal variations of very hot and very cold that might have an effect on the growth of those microorganisms inside a high water activity product in a package. Finally, the role of the package as the consumer's communicator, which is of course labeling. A package label tells you a lot about the product, its identity, its nature, its quantity, its qualities, its sources, warnings about its ingredients. It tells its retailer about the stock levels, and it tells the ultimate consumer about maybe what the end of life fate of that packaging material is. My little cartoon here is to try to warn you not to try developing your own labels at home unless you have the necessary knowledge, experience, and skill to do that right. There is a focused practice within the EAS universe of experts that's skilled at reviewing labels and developing labels for new products that will keep you out of trouble with the government. If you think about it, I think of the message on a label or the printed material on a package to be the original multitasker. You have regulated information describing the product and warning about the contents of the product. Then you have various usage type things that tell you, give you maybe a picture of what the product is to look like after it's prepared to eat, and they give you some directions to get that product from what it looks like coming out of the package to what you want it to look like before you're going to eat it. I'll point out that in our multicultural, multilingual, sometimes spotty reading ability population, you might think that pictograms or imagery on labels would be an acceptable way to communicate what you're trying to communicate with your label declarations. I'll point out, though, that it's not at all legal to try to substitute one picture for any number of words. In fact, the labeling world is a matter of 1,000 words. By way of example, FDA in this part of 21 CFR takes 38 paragraphs and about 3,000 words to explain to you the rules for listing ingredients of your product. Similarly, another part of 21 CFR uses 28 paragraphs and 1,600 words to tell you things like how to declare the country of origin of your product. This is a very complicated one. Cattle born in Mexico, raised and then slaughtered in the United States, and then details on what and where you can put on your label in terms of front, back, and side panels and the order of those that appear on your label. Even images like this barcode and the US FDA organic hallmark are subject to regulations and licensing contracts that have thousands of words. And a word of warning, words can hurt you. This is maybe a trivial example that struck me at lunch one day with some friends. Some of us had classic, some of us had baked, both salted snacks. The classic are slices of potatoes as they came from the farm that are processed and then put in the bright yellow package. In contrast, baked are baked potatoes with a lot of potato solids and some other ingredients that are rolled out in a flat sheet and then pressed into whimsical shapes that were never experienced by those potato farmers in Idaho, Florida, or Maine. And the products have to be labeled differently. Here's the acceptable designation for the classic. They are in fact potato chips because this is the shape of the slices that came off the potato from the farm. Potato crisp is a term of the trade that's used as a result of a mid-70s decision by FDA to restrict the use of potato chips as a term to the potato faithful slice of whole potato, not the mashed potatoes reconstituted into different shapes. I'd like to simplify the world of labels, but it's going to be difficult to do under current circumstances. But let me point out that I have hope for the future. And basically, you can communicate the same things, the legal requirements, the commercial brand information, and maybe some other information by providing a quick read code on the package that can then be read by a smart reader like your phone or iPad, and then reference to a URL in the Internet of Things that keeps track of the details that are in fact the nature of all those labels. Again, an example back to our potato chip bag. As you see here, this is a screenshot of my smartphone after it decoded the quick read code here on the back of the potato chip bag. This is a proprietary smart label product database management system that's licensed by the organization and many other consumer goods companies. It gives you basically the regulated product information that is required by the FDA or FDA in the United States, by the Department of Agriculture, I should say. It provides information from the brand owner about the brand and maybe some of its sister brands in the salted snack marketplace. And in this case, it provides a parent company statement about their global sustainability program. The advantage of this database approach to labeling information is that it's literally changeable at the click of a mouse. In contrast, labels and printed packages are just that, they're printed, and it's not possible to erase and reprint that packaging material. So every year, hundreds of tons, if not thousands of tons of pre-printed labels and packaging material are destroyed before they ever leave the package manufacturer shop because of changes in the supply chain that change the ingredient panel of that packaging, and it may reflect regulatory changes in the necessary information and definition of the regulatory requirements here. So with that hope for the future in mind, I hope that the future of the Internet of Things is closer than you might think, and pause and ask you for any questions at this point. Thank you.
Great, thanks. Everyone who has a question, please enter it into the Q&A box. We do have our first question here, and that is, how is packaging related in reference to Prop 65?
Packaging is considered part of the product by definition, whether it has that FDA trigger for becoming part of the product or not. So packaging materials that contain substances listed by Prop 65 have to be labeled as such along with the package. And it's my practice to advise packaging manufacturers to stay away from any of those Prop 65 substances, because you don't want to go to your food processor customer and tell her that she has to put a warning label on her product because of your packaging material. So very good question, and very specific in terms of the United States marketplace. And don't overlook the power of Prop 65 in your bills of material for making packaging materials for food.
Thank you for that. The next question, what heavy metals testing is generally targeted for packaging?
The best management approach for heavy metals in packaging material is supply chain management. It basically takes on the same kind of daisy chain of compliance statements up and down the supply chain, so that the pigment suppliers to various kinds of ink will certify to the formulators of the ink in terms of the press ready ink that the amounts of heavy metals, cadmium, lead, mercury, and what am I missing there? Hexavalent chromium are less than the so-called CONAG regulations that are now part of the toxics in packaging management group in the United States. So it is the case that the compliance with this is pushed into the supply chain rather than managed as a laboratory test done at the end of the line. And of course, as with any management system, you want to trust your suppliers, but verify that they do what they say they do, and maybe do some spot checks of the products you buy from them all the way up and down that supply chain. Just again, good management practice for food safety or any other kind of safety for that matter. Okay.
Great, next question. Are there any regulations on the migration of chemical compounds from plastic packaging to food in contact? Are there limits to overall migration or specific migration?
In the United States, yes, but they are hard to find. You have to find the specific substance that's involved here, and you have to understand the statement of composition and the limitations, the specifications that go along with that definition. It's nowhere near as straightforward as the dozens of pages that are in that single directed list from the European Union. But at the same time, I'll point out that there is no overall migration limit. There's the assumption that anything that migrates from that packaging material into the product has been approved for that use, that envisions that in fact that migration will take place. So I should have mentioned it earlier, but you as a packaging manufacturer are responsible to produce a package that complies with the packaging regulation rules that are in place for the marketplace where your packaged product will be marketed to either a retail or a wholesale institutional type customer. So know where your product is going before you decide you can sell it to the marketplace accordingly. Okay.
All right, we've got our next question, and that is back to Prop 65. If the label is printed with a Prop 65 substance, does this need a warning on the package?
If the label is affixed to the package, no, the package does not have to be independently indicated as such. You can word the warning on the label to refer to the package material rather than to the product inside the package. Again, I'd refer you to the experts at EAS to deal with label compliance like that. It's just too it's too detailed. It's a case where you don't have to worry about the little details, but all the details are big. So use an expert to make sure you're in compliance with that. Okay.
Next question is, are migration tests required by the regulation?
Migration tests are part of the specifications for the composition of materials that are cleared for use in food packaging materials. It's typically the case that in the process of the old food additive petition in 21 CFR that extraction data were included in the petition to the FDA for its ultimate clearance. And it is presently the case that under the chemical considerations, the guidelines of the FDA for submitting your food contact notification data, that you include relevant migration data associated with the substance for which you're seeking the notification. And I'll point out that it's critical in the context of that food contact notification review that the applicant indicate that good manufacturing practices are in fact in place in such a way that the resultant migration or extraction studies come out as clean as they are when submitted to the agency. It's definitely the case that a slip up in those good manufacturing practices could change the result of those migration and extraction tests. But at the same time, I'll point out that the theory of this data submission under the food contact notification system is that your process is under control and that your good manufacturing practices are preventing excessive migrants or extractants from showing up in your packaging material as it goes into the supply chain. So that's really handled at the approval level, unlike the European migration overall and specific limits that are addressed even experimentally, or I should say analytically, at the point of manufacture of the container itself. So big difference there in terms of what's tested for migration and when it's actually tested. Okay.
Perfect, thank you. While we wait and just see if anyone else has any final questions, speaking of labeling, I'll mention starting October 4th, we have our Food and Dietary Supplement Labeling Compliance Seminar. Of course, that's virtual. Information is on our website. And for the person who was asking specific questions about Prop 65, we did have a webinar, and I think it was last year on Prop 65. So I will send you a link for that. You may wish to watch it as well. And I don't see any final questions. I do see a number of people who have said, thank you very much, Tom, for a great presentation. Thank you everyone as well for joining us. We always appreciate your interest in EAS. If EAS can be of help with food packaging or any other regulatory requirements, of course, we invite you to reach out to us. You are able to contact Tim Lombardo directly. He's our Senior Director for Food Consulting Services. He can put you in contact with Tom, and we will get your packaging questions answered. So thanks, everyone, and have a great afternoon. And thanks again, Tom.
Bye.
Bye.